Hello student, let's try to understand types of decomposition reactions. If you see, the first one is thermal decomposition reaction that we are looking for. What you will find, student, here the experiment to illustrate thermal decomposition reaction. First of all, you see the experiment number 1, thermal decomposition of lead nitrate. What is there, student? Take powder lead nitrate in dry test tube, hold it in the test tube holder, heat it over the flame. Brown fumes of nitrogen dioxide are formed to evolve. Yellow residue of lead oxide is left behind in the test tube. This is due to the following decomposition reaction. So 2 molecule of lead nitrate is there, student. This is, and if you see on heating, it will giving the 2 PbO plus 4 NO2 plus O2, and this is what is the brown fume, student. So one molecule decomposing to give the one compound decomposing to give 3 different type of the compound, so that it become the decomposition reaction. And since the heat is being used, that is why it is called thermal decomposition reaction. Here you can heat it, student. So what you will find, reddish brown vapors of nitrogen dioxide is formed. So this is the reactions. Now see the experiment number 2, student. What is the experiment number 2? Thermal decomposition of ferrous sulfate. Take a small amount of ferrous sulfate crystal in dry test tube, holding the test tube in test tube holder. As in above experiment, heat the test tube strongly over flame of the spirit lamp or a burner. We observe that the green colored ferrous sulfate crystal FeSO4.7H2O on heating first lose water and color change to form the anhydrous FeSO4. So here is the FeSO4 is there, student, ferrous sulfate crystal you are heating. So it will give the anhydrous ferrous sulfate plus 7H2O. So this is the loss of water, it is there. Now see, this on further heating give out the characteristic smell of burning sulfur, leaving behind a reddish brown residue of ferric oxide. This is due to the following decomposition reactions. What this is, the student, thermal decomposition of ferrous sulfate. So you will find, student, sulfur dioxide and sulfur dioxide gas is getting evolved, student. Okay, and what type of gas is being residue is the, what is a brown residue, reddish brown residue of ferric oxide, student, is being also formed. What is the characteristics? Burning sulfur leaving behind, characteristic smell burning sulfur. Okay, rotten egg like smell sometime it's appear, student. Equation you can see, FeSO4 is there, 2 molecule, Fe2O3 ferric oxide plus SO2 plus SO3. Okay, similarly copper sulfate crystal CuSO4.5H2O which are blue color on heating 100 degrees Celsius lose 4 water molecule to form copper sulfate monohydrate, which is bluish white powder, which on heating to 230 to 250 Kelvin loses H2O further to form anhydrous copper sulfate, which has white color. So CuSO4.5H2O, it is going to give CuSO4.H2O, and which again it is give CuSO4. Now see, the anhydrous salt on heating is strongly decomposes, yielding copper second oxide, sulfur dioxide, and oxygen as follow. So 4 molecule CuSO4, so it is giving 4 CuO plus SO2 plus SO3 plus O2. While performing this experiment, keep the mouth of test tube away from yourself as well as from your neighbors. Some more example of thermal decomposition. Decomposition of calcium carbonate, you will find it will give CaO plus CO2. This is the decomposition reaction because the single compound CaCO3 on heating is split to form simpler compound CaO and CO2. Decomposition of the potassium chlorate on heating in the presence of manganese dioxide, that is 2KClO3, it will give, that is 2KCl and 3O2. This reaction is used for the laboratory preparation of oxygen. Decomposition of zinc carbonate, you can see it will give ZnO plus CO2. Decomposition of copper nitrate, it will give CuO plus O2 plus NO2. This is also brown color. decomposition of potassium nitrate KnO3, it will give KnO2 plus O2. So this is the thermal decomposition reaction, student. You can make the note of it, and in the next video we will go for the electrolytic decomposition reaction. Thank you very much for watching, students.